Hi folks, part 5 video of the miscellaneous exercise. We had finished till what? Till 11th problem. Now 12th, and let's see how much you can do it. So let's look at the 12th problem. It tells us that Z1 is something and Z2 is something. If that is the case, they ask us to find the real part of Z1, Z2 by Z1, a new complex number. They ask us to find out a new complex number which is like this and find its real part. Another complex number which is of the type 1 by Z1, Z1 bar, and we have to find its imaginary part. So let's start right away. Let's consider this. Consider Z1, Z2 by Z1 conjugate. Z1, Z2 means it's 2 minus I into minus 2 plus I, and Z1 conjugate means it's 2 plus I. So let's see how this goes. Let's take the expansion, this into this, this into this. So minus 4 plus 2i, and then plus 2i minus I squared by 2 plus I. So this is 4 and this is plus 1. So yeah, because minus is there and I squared is minus 1. So that way this will come to minus 3 plus 4i by 2 plus I. We don't much like this I in the denominator, so we multiply by conjugate and try to make it in our standard form. So we will be multiplying by 2 minus I both in the numerator and denominator. Denominator we know becomes x squared plus y squared, so it will become 2 squared plus 1 squared. And here then we'll go in for the expansion. Minus 3 into 2, it's minus 6, minus 3 into I plus 3i, then 4i into 2, 8i, and minus 4i squared. Let's see how this comes. 2 2s are 4, 4 plus 1, 5. How about this? Minus 6, will this become plus 4? Because minus and I squared is minus 1. Minus 6 plus 4, they're like terms. So it will become minus 2. And over here, 8 plus 3. Yeah, it's 11i. So when we write it in A plus IB or standard form, this is what will come. But what is the question? They ask us to find the real of this. So the real part of Z1, Z2 by Z1 bar comes to minus 2 by pi, isn't it? That's a real part. Just quickly cross check it and see if it's right. Yes, it's minus 2 by 5. That's about the first part. There is another part which says that it is, you will find the imaginary part of 1 by Z1, Z1 bar. So let's consider that. Consider 1 by Z1, Z1 bar. Z1 we know is 2 minus I. Z1 bar therefore is 2 plus I. So our good old formula x squared plus y squared can come into play. Yeah, that we have done it here. Yeah. We have already done that 2 squared. Yeah, here. It's 2 squared plus 1 squared. That's 5. Earlier we have seen it's 1 by 5. But this, when we write it in standard form, it is 1 by 5 plus 0i, because there's no imaginary part that's coming. And question says, write the imaginary part of this complex number. You have to write the imaginary part of this complex number, and that is 0, because there's absolutely no imaginary part. So that's about the part 2 of this problem 12. Now we'll quickly go to problem 13. They ask us to find the modulus and argument of this complex number. So first let's reduce this complex number into standard form, and from there modulus and argument we know we have got the formula, and from there we can find it. So let's consider this first. 1 plus 2i by 1 minus 3i. As we say, we know if we are not into a form that we like the denominators conjugate, we multiply both in the numerator and denominator. So you have 1 plus 2i getting multiplied by 1 plus 3i, because that's a conjugate of the denominator. Okay, the denominator, because we conjugate x squared plus y squared we know, so it's easy. It's 1 squared plus 3 squared. And here then let's take it like this. 1 plus 3i, 2i plus 6i squared. Let's check what happens here. 9 plus 1, 10. Okay, 9 plus 1, that's 10, and these both are like, this is minus 1. So it's 1 minus 6 minus 5. How about this? 5i. So minus 5 by 5i. If you want, you can write it as minus 5 by 10, so minus 1 by 2, 5 by 10, 1 by 2i. So what happens here? The x is minus half and the y is half. So that readily gives us r, which is x squared plus y squared, which is what we call it as a modulus. So that is x squared means 1 by 4, y squared means also 1 by 4. Denominators, as I can add the numerators, it's 2 by 4, or rather half. So that is 1 by root 2. So your modulus is 1 by root 2. Then argument. For argument, first we have to see which quadrant it lies, then find the theta. Now, for that we require one more thing. We know that cos theta is x by r, sin theta is y by r. How about cos? It's minus half by 1 by root 2, and this is positive half by 1 by root 2. How does it solve? See, minus 1 by 2 into root 2, division by a fraction is multiplication by the reciprocal, and that way, this is because it's root 2 into root 2, the 1 root 2 will cancel and you'll get 1 by minus 1 by root 2, so also here it will be positive 1 by root 2. So cos is negative but sin is positive. Where does this happen? It happens in the second quadrant. So therefore argument to start with is in the second quadrant, which is pi minus theta. Now to decide theta, look at the values, we'll get to know. 1 by root 2, which cos is 1 by root 2 and which sin is 1 by root 2? 45, which means pi by 4. So pi by 4 on equalizing into 4 into 4. 4 pi minus pi, 3 pi by 4. That's all. So the modulus and argument is done. For us, modulus is 1 by root 2 and argument is 3 pi by 4. That's about this, and that's all in this video. With the next two problems in the new video. Thank you.